Okay, so what do you need for point slope form? It's called point slope form. So you need a point and you need a slope. Hey, and then we have what we need for point slope form. Do you get it? I know, right? Okay. So y is always going to stay as y. X is always going to stay as x. That's how we have the equation. Okay. Whatever our point is, we're going to plug in right here. And whatever our slope is, we're going to plug in right here. Okay. So I want you to graph the point 2, -2. And the point. Three, 1. That's not right. 4, 1. Okay, when we have a graph, finding slope is pretty nice, right? Because we can just look at rise over run. Okay. Colin, what is our rise over run?
3/2.
Okay, our rise is 3, our run is 2. Okay. Okay, so here I have a point. Here I have a slope. And we can write we can replace the y1 with a 1, our slope with a 3/2, and our x1 with a 4. I replace my slope with slope, and I replace my point with the point. Finish your notes out.
I cleaned my backpack out like 30 days ago. And
You need something to write down.
I was trying to make it unheavy.
I believe you.
Yeah.
The 4 and 1, how do you know that you're using that? Because what if that means 1 X and 1 Y?
Hmm?
Oh, because there was an extra.
Okay. Did somebody else have a question? Did I? Like, this is where we replace our point. So x1, y1, I put in 4, 1. Oh, why wouldn't I use the other one? Doesn't matter.
No.
So let me show you. Y minus 1 equals, if I distribute the 3/2, we have 3/2 x minus, what is 3/2 times 4? Not everybody all at once.
12, 6.
12/3. That's a 6, not 3.
So 3/2 times 4. 3 times 4 is 12, divided by 2 is 6. Okay. And so then if I wanted y by itself, I could add 1 and we get y equals 3/2 x minus 5.
Wow.
Does that look reasonable for that graph?
Yeah.
Okay, now Amelia said, well, why did we use 4, 1 and not 2, -2? Guess what? It's not going to matter. Let me show you how. So y minus y1 equals slope times x minus x1. So now let's use our slope of 3/2 and let's use the coordinate 2, -2. So instead of writing y minus -2, are you okay that I just went straight to y plus 2?
Yeah.
Okay, so now watch. I'm going to distribute and I get 3/2 x minus, what is 3/2 times 2? Yeah, that time it's 3. Okay. And to get y by itself, I'm going to subtract 2. So we get y equals 3/2 x minus 5 Amelia. Is that the same thing? That is crazy.
That's crazy.
We got the exact same line. So let's go back to Amelia's question. Does it matter which point we use?
No.
No. As long as the point is on the line, when we rewrite it to our y equals mx plus b, it's going to be the same thing. Okay. So this is what I want you to do. I want you to turn to yes. And I want you to write me number 1. I want you to write it in just point slope form. Just write point slope form, number 1. Just point slope form. Okay. Andrew, what do you have for point slope form? Okay, so what numbers did you plug in? So we got to plug these numbers into that. So we would have y minus, what would go here? 1 equals times x minus -2. So we're going to x plus 2. So this is point slope form. That is exactly what they're asking for. Point slope form. Okay. Now, what I want you to notice about number 7, what form are they wanting? Slope intercept. Peyton.
So for writing the point slope in the coordinates, that's what you plug into the x1.
Yep.
The y1.
Yep. Yep. Okay. Now, over here, I just wanted point slope form. Down here, I actually want slope intercept form. So, like, let's look at number 7. Is that the one? Yeah, sure. What is our rise over run? So our rise is 4, our run is 2, so our slope is. Okay, Amelia, does it matter which points we pick? No. Amelia, which point would you like to pick? I agree with that. I want to avoid negative numbers. Okay. So we're going to take y minus y1 equals slope times x minus x1. Okay, we know that our slope is 2. And we know that our coordinate is 3, 2. Okay. So now to get this into, you did it. I'm so sorry. Thank you. So now to get this to look like y equals mx plus b, hey, we already kind of talked about doing this, didn't we? What do I need to do on the right side? Distribute.
We add 2 to each side.
Okay, now I need to solve for y. Let's add 2 to each side. So y equals 2x minus. No, that's it. Like, we stop. Now, does this look like this graph has a y-intercept of -4 and a slope of 2? Yeah, it does. Nice work. Now, what if we don't have a graph?
Make a graph.
No, we don't need to make a graph. Go to number 14. Go to number 14. This notation, I don't know what it means. Somebody help us. Sophia. Okay, so what do you mean by it's just the coordinates? Can you tell me what the coordinates are? I cannot hear you. That? Okay. Here are our coordinates. So if I want to write a linear function, what do I need? A linear function, what? Yeah, if I have 2 points and we're talking about a line, you better find slope. Find the slope. Find me slope. I'm hearing 2. Somebody said -2. Oh, people, rise over, run. So we need to take 7 minus 1 over 1 minus -2. So we have 6 over 3, which is a +2. Reagan, did you find your mistake? Okay, well now I need to write a linear function. Oh, what do I do? Okay, so here I have slope. What do I do? I have slope and I have, technically I have 2 coordinates. Doesn't matter which one we use. Let's do it. Okay, so y minus 7 equals slope times x minus 1. Okay. So y minus 7 equals 2x minus 2. Add 7 to both sides, so 2x plus 5 is y.
I want to turn to that number 21.
Writing linear models, kind of a big deal. Read through what Craig is doing. And number 21, read through it silently. You remember that whole conversation I had with the class? Odometer just counts the number of miles. Well, just like it's just continuous.
Oh, so that's why.
Wouldn't it be 180 miles? It'll be
Okay,
1 mile per minute.
okay. First of all, is there a number that correlates to a constant rate of change? Oh, 60
But that you can't get
is,
five.
hold on, is a constant rate of change. What do we call that in linear functions? A constant rate of change? What characteristic of a line is the constant rate of change?
Along with 2 arrows.
What?
Along with 2 arrows. Linear function? A continuous line.
Didn't hear it. Didn't hear it. Constant rate of change is slope. Like that's literally what the definition is. So our slope, cool, is 3. Okay, no, our slope is, 60. Okay. After driving for 3 hours, his odometer reads 265. So, D is like our Y. And H is like our X. Okay. So after 3 hours, he has driven 265 miles. So they want us to write a linear function. Hey, guess what? We have a point and we have a slope. We can do that with point slope form. Okay. I don't see a 5 anywhere.
Because it says 65 miles. You get that from.
Well, just, yeah, you can, you don't have to drive exactly an hour. You could drive part of an hour. Right? So instead of y minus y1, I'm going to write d minus d1 equals slope. Instead of x minus x1, I'm going to write h minus h. It's the same thing. I'm just using d's and h's. Are you okay with that? Is that going to freak you out? Okay. Our slope is 60. And our coordinate is 3 to 65. Well, I'm really gonna need some help. Oh, no, it's not that bad. So we have 60H minus 180. But this is what I'm gonna need help with. If we add 265 to both sides, would it be 85? 85? Okay. So here's our equation. Now, what does the odometer read after 7 hours of driving? How do I find that out?
You replace H with 6, replace H with 7.
Okay, for this, we're gonna plug 7 in for H. To get 505 miles. Now, this person obviously didn't have to like slow down for traffic or you're running across the road or
Mommy, I just
zooming. 60 miles per hour isn't zooming.
But if you hit 265 miles per hour.
What?
No, if you hit 265 miles, sorry, in 3 hours.
That's like more than 2 miles.
Yeah.
I don't know how you can argue with that.
'Cause-
People, look at this. This is our y-intercept, right?
Oh.
He had 85 miles on his odometer before he started driving. It's what reads the miles.
85 without doing all that stuff.